Hello everyone, I'm very glad to have a presentation to share our research results of single wavelength BIDI transceiver. This innovative technology is different from the conventional BIDI because it has three major advantages. First, it simplifies the carrier's inventory management and the network construction. Second, it doubles the wavelength capacity. Third, it reduces up and down link time difference to picoseconds level, so it meets more rigid specs of the next generation system. The technology will bring significant improvements to optical network. Let's start from wireless network evolution history. Wireless communication starts from 1987. It uses analog signal and can only support voice call. From 2018, we enter 5G year. Its peak bandwidth is up to 10 Gbps per second, and the air interface delay is down to 1 millisecond. Several new applications are booming within 5G, such as intelligent manufacturing, remote medical, and vehicle network. In order to realize robot real-time synchronous cooperative, the network delay should less than 1 millisecond. In remote medical scenario, low latency network is needed to meet remote endoscopy and ultrasound force feedback requirements. 4 and L5 level automatic driving needs less than 10 centimeter position accuracy, so picosecond magnitude time synchronization is mandatory. All the new applications need low latency network, so low time delay between transceiver upstream and downstream is very important. Now, 5G network is widely deployed in worldwide. Its backhaul and fronthaul construction are facing tremendous challenges. In backhaul, BIDI transceiver can save fiber resource, but it introduces management complexity and cost due to two kinds of optical transceiver are used, and its synchronization time doesn't meet automatic driving requirements. In fronthaul, some wavelengths suffer laser materials or high dispersion penalty, so fronthaul network capacity is limited. In other words, we need a new technology which within one fiber and a one-time transceiver advantage together. Traditional BIDI use two wavelengths for transmitter and receiver. TFF works as max and demax. Its path and reflection wavelength bands are fixed, so each fiber connection needs two cans BIDI transceiver. Single wavelength BIDI can normalize transceiver to one time, so it always been interested by the industry. But traditional single wavelength BIDI based on 3dB splitter and circulator both suffer high loss and crosstalk from reflected transmitter to receiver. Then it doesn't meet ODN reflection tolerance spec. So single wavelength BIDI never being commercialized. The innovative single wavelength BIDI in this presentation solves about problems perfectly by using tunable filter. Because transmitter and receiver wavelengths are different, so its reflection transmitter to receiver crosstalk is as small as normal BIDI. By tuning laser and filter wavelengths, transmitter and receiver wavelengths can be exchanged. Then two transceivers of one fiber connection can be normalized. Furthermore, transmitter and receiver wavelengths are close to 0.5 nanometer. Then the time synchronization accuracy can reach picosecond magnitudes. This single wavelength BIDI is two working modes, so two transceivers can set up communication link when their working modes are different. At the system initial phase, two BIDI transceivers are both power on. The first part will set itself to mode A by tuning laser and filter to mode A working temperature. Then let its laser always working. The second part BIDI will receive the mode A transmitted light, then set itself to mode B by setting its laser and filter with mode B parameters. Compare normal BIDI. Its single wavelength BIDI not only normalized transceiver, save 50% wavelength resource, but also suppress round-trip transmission delay to picosecond magnitude. This innovative single wavelength BIDI performance is tested comprehensively in test beds. According to spectrum test results, we can find upstream and downstream wavelength difference is only 0.41 nanometer, which guarantees the time synchronization accuracy to 0.25 nanometer. BIDI, OMA, ER, and DIQ all meet 50G base ER spec and -5, 35, and 75 degree. Receiver sensitivity is also tested under -5, 35, and 75 degree. Test results show that whatever mode A and mode B, its sensitivity are all meet 50G base ER -14.1 dBm spec. We also achieve 24 hours error-free real-time transmission in 50G base ER point-to-point system over 40 kilometers G.652.D fiber. Single wavelength technology has a lot of application scenarios. First is a backhaul. Single wavelength BIDI transceiver can be used in 5G backhaul to save not only CapEx and OpEx, but also eliminate time measurement and compensation procedure. Second is fronthaul. By using single wavelength BIDI technology, we can use 6 matured wavelengths for 6-channel application to reduce laser costs and dispersion penalty. We also can use 12 wavelengths for 12 channels application. We enlarge system capacity to 2 times without introducing new laser. All other scenarios which use normal BIDI also can be replaced by the single wavelength BIDI. Make a summary. Single wavelength scheme is a promising approach for BIDI application. Test results show that both stability and power budgets are satisfied using a 50G base ER spec. Based on its excellent performance, this technology will shape optical communication network. Thank you.